the product and quotient of powers. Expand 10 to the 6th. So right now it's in exponential notation, so what it means is 10 times itself 6 times. So if we expand 10 to the 3rd, it means 10 times itself 3 times. So what does it mean when it says expand 10 to the 6th times 10 to the 3rd? What do you notice? So if we have 10 to the 6th, we have 6 tens again, and then we have 3 more tens. So I'll move it over a little bit, give it a little space between the 10 to the 6th and 10 to the 3rd. You should notice that it's really 10 to the 9th power. So if we were to expand a to the 4th and then a to the 5th, okay, same type of question, but now using variable. So we have 4 a's, and then we have a times itself 5 times. What do you notice? So now if we multiply those two together, if I wrote out a to the 4th again and a to the 5th again, you should notice that we would have a to the 9th power. So what's happening? What is going on? It says when you find the product. So product means when you multiply the product of two algebraic expressions with the same base. Same base is a key piece of information here. Okay, we had a to the 5th and a to the 4th, or we had 10 to the 6th and 10 to the 3rd. You can, here's the big understanding, you can add their exponents and use this exponent with the same base. Okay. Go ahead, flip the page. So now we just have a bunch of practice questions. It says write your answer in exponential notation. So in that first one, my base is -4. So I'm going to write it just the way the problem wrote it. Put parentheses around your base because your whole base is -4. If I have 2 -4s and then I have 3 more -4s, that gives me a to the 5th because I'm adding those two exponents. Same base. Number 8, 3 to the 6th times 3. So what's the exponent to that 3 there? That's a 1. So my base, I'm going to put it in parentheses, is 3 to the 6 plus 1, which is 7. a to the 23rd times a to the 9th is a to the, I'll write this one out, 23 plus 9, which gives me, I'll put that a in parentheses again, okay, a to the 32nd. I don't know where that red line is coming from. Something's going on with my stylus, apparently. Next one, number 10. Maybe if I change colors. So f to the 10th times f to the 13th. So 10 plus 13. Oh, gracious. I don't know what is happening with that red line. 10 plus 13 gives me, I'll put my base in parentheses, f to the 23rd. Get the idea? All right, next one. 1.2. We have 3 of them, then we have 4 more of them. 7. -5. I could write that Negative 5 is my base. There we go. Remember, that exponent that is with that negative 5 right there is to the first power. So we've got one of them, then we have 5 more of them. So that gives us negative 5 to the 6th power. Okay, fractions, changing it a little bit, but it's still the same idea. What's the base? 1/5. And we have 6 of them and 11 more 1/5, which gives me 17 1/5. My base is negative c. I have 4 of them, then I have 8 more, and we're multiplying. When you multiply like bases, add exponents. Always say that in your head. When you multiply like bases, add exponents. So 4 plus 8, 12 of them. Okay, same thing with 15. 9, we have 4, then we have 6 more, then we have 13 more 9s. If I were to expand all that out, I would have to write 9 23 times. Okay. 16 looks a little bit different because now we've got 6's and we have 4's as bases. So let's just focus in on the 6's. We have 6 to the 5th and 6 to the 14th. So 6, 5 of them, and 14 more gives me 19 of them. Put that in parentheses. So 6 to the 19th times, now focus in on the 4's. Okay, so we have 4 to the 9th and 4 to the 3rd. That gives me 4. 9 plus 3, 12. 17, same thing. Okay, 2 different bases, that's okay. That exponent to that 15 is 1. So 15, we have 2 of them. Then we have 1 more. So that gives me 15 to the 3rd times, my stylus, oh, there we go. 7 is my other base. So we have 2 7's and 4 more 7's. So 7 to the 6th power. Can I do anything different with 18? I have a base of 5, 5 to the 4th, but then my other base is a 2. Can I put those two together? Do I have like bases? I don't. One's a 5, one's a 2. Can't do anything else with that. That has to stay exactly the way it is. Okay. So go ahead and pause the video right now and try some of these on your own.
Call from.
So now let's take a look. So check your answers. And I do want to talk about 20 and 22. So something different about 20 is you have a 2 and a 3 there. So you can multiply those because those are just whole numbers. 2 times 3, that's where I got that 6 from. And then it's x to the 6th, y to the 8th. And same thing with 22. Where did that 20 come from in my answer? It came from those two whole numbers, 4 times 5, which is 20, and then s to the 8th, t to the 9th. So picking up with number 23, I have a times the quantity of a plus b. Well, the distributive property needs to be done there. So that's something you learned last year in 8th grade. So let's think about how are we going to use the distributive property with this. And I put all little exponents of 1s for all of those. So what is a to the 1st times a to the 1st if I start the distributive property? That gives me a to the 2nd power, because 1 plus 1. And then if I were to continue and say a to the 1st times b to the 1st, that's a plus a to the 1st, b to the 1st. We can't add those exponents, but we can multiply them. We can multiply the bases. We just can't add the exponents because one's an a and one's a b. So if you wanted to, you certainly could write a squared plus ab. You don't need to write those exponents as ones. So 24, we just flipped things around a little bit, but it's the same idea. We have a 1. All of those exponents are ones. We're still using the distributive property. So we end up with A, B. I put it in alphabetical order. We could have said BA, but I put those letters in alphabetical order, and that's totally acceptable. Plus B to the first times B to the first gives me B to the second. Go ahead, turn the page. Okay, so now, same idea, but we've got some different things to look at here. It says if negative 3 to the 9th times negative 3 to the x. I don't know that exponent right there. It's equal to negative 3 to the 14th. So you have to think in your head, 9 plus what number would give us 14 nines? And that's going to be 5. So x would be 5. I'd need 5 more 9s. Or excuse me, 5 more negative 3s. Okay. You can pause the video and try 26 and 27. So that's what 26 and 27 look like. Now we're going to take it and divide. So you're going to take that 5 to the 6th divided by 5 to the 2nd. So 6 of those. Divided by 2 5s. Now what happens when you divide something by itself? 5 divided by 5 is 1. 5 divided by another 5 is 1. Do I have any more that I can divide out? I don't. So what am I left with? I'm left with 5 to the 4th. What just happened there? So, got another problem. Okay. Go ahead, pause the video and do 29 and 30. Doing the division after I expanded those out, and now I start to say, okay, y divided by y is 1. Another y divided by y. Cancel out, okay, or reduce those. What are we left with? We're left with y to the 3rd. So what happens when you divide like bases? Let's see what our little summary says. When you find the quotient, there's your division, okay, of two algebraic expressions with the same base, you can subtract their exponents and use this exponent with the same base. So it's kind of nice how that works. When you multiply like bases, you add exponents, but when you divide like bases, you subtract exponents. So always say those two things in your head, and you shouldn't have a problem with the product or the quotient rule. Let's take a look at this next page. So again, some more practice problems and some division. So 2 to the 9th divided by 2 to the 6th. I might rewrite that as a fraction. 2 to the 9th divided by 2 to the 6th. Like bases, subtract exponents. 9 minus 6, 3. Negative 7 is our base. And let's find out what exponent that would be when I divide. Remember, there's that 1 there, so 5 minus 1 is 4. 3 to the 5th is the base. 8 minus 6, because we're dividing, 2. Again, keep in mind all the time when you're dividing, you subtract exponents. There's our exponent of 1 and 35. So what's my base? 5 to the 8th. I'm dividing, so it's 6 minus 1, 5. There's my base. I'm dividing, so I subtract exponents. 7 minus 2, 5. I'm going to put this base in parentheses because it's negative. That's the base, negative p. 5 minus 3, 2. Go ahead, pause and practice. So let's talk about those. So h to the 6th and h to the 5th, k squared, k to the 1st. Remember, like bases, you subtract your exponents. So I had to focus in on those. So that gives me h to the 1st, 6 minus 5, and k squared, k to the 1st, 2 minus 1, k to the 1st. And then 39, 28 divided by 7, that's where that 4 comes from. And then looking at the m's, m to the 7th and m to the 3rd, 7 minus 3, 4. And then the n's, n to the 4th divided by n squared gives me n squared again, because 4 minus 2 is 2. Same thing with 40. 41 through 43 are some challenge problems. You can, I'm going to give you some hints. I'm going to put ones underneath. And you can stop here, or you can challenge yourself and walk through these. So if you'd like to be done, you can be done. If not, I'll go through 41 through 43. So these are your challenge problems. Ready? So what I would do first here is I would multiply, because we've got fractions. I would multiply across the numerators. So that gives me 15 x to the 8th divided by, then I have the denominators. X to the 3rd times x to the 1st is just x to the 3rd. Now I have to simplify that. So that's 15, and now I've got those like bases, and we're dividing, so we subtract x to the 5th. Next one, do the same thing. Multiply across, negative 20x to the 6th, multiply the bases, or excuse me, multiply the denominators, x to the 3rd, now simplify. Negative 20, we've got like bases with the x's, and we're dividing, so subtract. 6 minus 3 is 3. And then the last one, same thing, multiply across the tops, 55 x to the 4th divided by x to the 3rd, simplifying, we end up with 55, and then the x's, x to the 4th divided by x to the 3rd, leaves me with x to the 1st.